So in this video, we are going to talk more formally about what a linear relationship is. And we've already talked about this so far. So a linear relationship occurs when a pattern or a table of values is going up or down by the same thing. So it's increasing or decreasing by a constant rate. If you were to graph it using a table of values and graph it on a Cartesian plane, you would actually see a line. So for example here, what we notice with this pattern in the table is that we're going up by 2 every time. So we would call that linear. Now, when it's linear, we know we could come up with the equation, right? So linear equations always have this format, something x plus something or something x minus something. So remember, this one we learned was the constant rate. And that's just what you're going up or down by. And then this one was the initial value. And that was really what value of y when x is 0. That's what the initial value is. So let's come back to this particular one. So we know that the equation has to be y equals something x plus something. So we know it's going up by 2. So that's our constant rate. Now, to get the initial value, it's a little bit harder when it's a table and not a picture. So remember, to get the initial value, one of the ways to do it is to work backwards in your table, 5, 4, 3, 2, 1, and just find the 0. If that were 0, 5, 4, 3, 2, 1, 11, 9, 7, 5, 3, 1. That would be our value of y is 1 when x is 0. Now, be very careful. You have to check that your x values are all going up by 1. If they're not, and we're going to look at one later, you have to do something a little bit different. So be careful with this. The other way to find the initial value is just to kind of do a bit of guessing and checking. So for example, like if I look at 3, 7, when I put in 2 times 3, I get 6, but the table's telling me 7. Or when I do 2 times 2, I get 4, but the table's telling me 5. Well, how do I get from 6 to 7 or 4 to 5? I need to add 1. So that's the other way of finding the initial value. So this is an example of a relationship where this is going up by 3, and then it's going up by 5, and it's going up by 7, and it's going up by 9. That's not the same. Therefore, it's non-linear. It's a pattern. Okay, this is a really interesting pattern, but it's not a line because we're not going up or down by the exact same thing. When I graph this, I would actually get a curve. So this one is actually a special relationship called a quadratic. There is a pattern, there is a relationship. It's just not a linear relationship. So be careful. Nonlinear relationships usually have exponents in them, so things like x squared or x cubed. I'm not going to be asking you to find the equations of nonlinear relationships. We're only going to be focused on linear relationships. So let's have a look at some examples. So let's first just answer the question, is it linear or nonlinear? If it's linear, let's get the equation. So first thing, again, we want to double check, are our x values going up by 1? Yes. Okay. Now, what are we going up or down by? In this case, we are going down by 4. That means this one is linear. It will have the equation y equals something x plus something. So y equals negative 4x. And then, oh, look, it was really nice, and it gave us the initial value. It gave us the value for y when x was 0. So we can just write it in. All right, let's look at the next one. This one, we're going down by 1, then we're going up by 1, and then up by 3. The pattern, it's not linear, not the same. So we're done. Okay, let's look at the next one. Again, we double check. Do our x's go up by the same? Yes. We find what we're going up or down by. We're going up by 2 every time. Therefore, it is linear. And again, this one was really nice. It gave us the initial value. It gave us the value of y when x was 0. By the way, you can always check if you're right by just substituting. Try 2 times 2 plus 2. What do you get? You get 6? Great, I'm right. Or 2 times 3 plus 2. Do you get 8? Yep, good, I'm right. Okay, so that one was linear. All right, so now let's look at this one. So again, we check our x's going up or down by the same thing. Yep. Okay. So down by 2, down by 2, down by 2. So linear. And this is y equals negative 2x. Oh, darn. This one isn't as nice. It doesn't give us the 0. So a couple things you can do. You can substitute. So I could try like, what's negative 2 times negative 5? I get 10. But this is telling me 8. Or negative 2 times negative 4. I get 8. But this is telling me 6. What am I doing? I'm subtracting 2. Just a coincidence that both numbers are negative 2. The other thing you could do is just continue your chart. 5, 4, 3, 2, go negative 1, then go 0. And negative 1 would be 0, and then 0 would be negative 2. So you can continue your table. All right, let's look at this next one. So the next one, we're going up by 3, up by 3, up by 3. It is linear. So again, y equals 3x. And then when we look at it, we see, don't see the 0. So again, you can go backwards in your table, like fill in 2, and then this would be like negative 7, and fill in 1, and this would be negative 10, and then 0 and negative 13. So that's one way. Or just substitute in, like what's 3 times 5? That's 15, but this says 2. Or what's 3 times 6? It's 18, but this says 15. So I need to minus 13. So that's another way to do it. All right, we're going to keep going. So let's see what's happening. We're going up by 1, up by 2, up by 3. It's a pattern, but they're not the same number. This one is non-linear. All right, a couple more to go. Okay, we are going up by 3, up by 3, up by 3. Linear. So that one's linear. Something x, in this case 3x. And then we find our initial value, or we substitute. And in this case, 3 times 3 is 9, or 2 times 3 is 6. So our initial value is 0. So we could write y equals 3x plus 0, or we could really just keep it as y equals 3x, which generally speaking is what happens. All right, last one. Down by 3, down by 3, down by 3. That one is linear. So y equals negative 3x. And then this one was, once again, very nice. Gave us the initial value. And those are our equations. So again, the steps we take, we look at the table. First, we check, do the x values all go up by 1? Then we check the y values. What's happening? Are they all going up or down by the same number? If so, we know it's linear. And then we can figure out what the initial value is. What we go up or down by is the constant rate, and we have our equation. If they're not going up or down by the same number, then it's nonlinear, and we're done. So let's look at one final example. This one's a little bit more challenging. So it's more challenging because when you look at the x values, they're not all going up by 1. So what do? Well, all you really have to do is rewrite the table and fill in the missing pieces. And I'm just going to go to 5, but for space. So 0 was negative 3, and 2 was negative 1, and 4 was 1. Well, what's happening in between? Well, I just have to fill in the pieces that are missing. Now my x's are all going up by 1. Now I can check what happens to my y's, and they're also going up by 1. Now I know that it is linear, and I can write my equation 1x, or usually people just write y equals x, and then it actually gives me my initial value, so minus 3.